Hello there and welcome to 9.6, and I need to get my PowerPoint started. That's the slide you should be on right there. I believe that's page 20 in your notes, and we're now talking about square roots, and that's going to lead us up to probably the most complicated math we've done up to this point, but we've simplified it for you. Hopefully make your life a little bit easier, and that's called the Pythagorean theorem. Maybe you've done it before, so you probably have no problem with it, I hope. So let's get some vocabulary out of the way. We have to start talking about this, what a square root is. And so I'll give you just kind of the math definition here. If a number is a product of two identical factors, then either factor is called a square root. If a is equal to c squared, then c is a square root of a. Here's what I mean by that. To explain this, it might be easiest if I consider, let's pretend that c, according to this, that c is 2. Okay, if c is 2, then it says a is equal to c squared. So that means a is equal to c times c. It's times c, which is 4. All right, so if c was 2, then a would be 4. All right, then what that means is that c is a square root of 4. Okay, so in other words, the square root of 4, that's written with that symbol there, is equal to 2. Okay, let's say that c was 5. All right, then a would be 25, because that's 5 times 5. So in other words, okay, square root of 25, square root of a would be 5 right there. So that's a square root. C is a square root of a. 5 is a square root of 25. 5 here is a square root of 25. So this symbol here, square root, which is here, that is called a radical sign or radical symbol, which is what we use to name square roots. Okay, so on the next slide you have just some blanks here. So what we have here is that means the square root of 81. Square root of 81 is 9. Now what you will need to be able to do is to use your calculator. And there it is. I'm able to pull it up there for you. Yours is probably a lot more simple than mine. So let's say I had 81. Let's see, I can't remember if I put the 81 in first. Yeah, 81, and then I hit my square root symbol. It gives me the square root. The square root of 81 is 9. You'll need to know how to use your square root button. It'll make your life easier for this. Let's try another one. 36. Square root of 36 is 6. Often, on a lot of the calculators, probably the one that you probably have to hit the square root sign first and then put the number in. You need to play around with it and get familiar with how the square root symbol works. If you're not sure or have any questions, bring that to class and I'll figure it out with you and show you just how to do that. More often than not, square roots are not really nice numbers. Like, here's more of a realistic one. If I try the square root of 13, and you'll see you're going to get a full screen of numbers there. It's called an irrational number. It means the decimal value, it repeats forever and ever with no pattern, making it irrational there. So again, the symbol that we have, square root sign, is that right there. So we could list several of them. Square root of 36 is 6. Square root of 4 is 2. So hopefully you get the idea right there on how that works there for you. So that's a square root. And then that takes us to this thing called the Pythagorean theorem that has to do with right triangles. In a right triangle, the longest side is called the hypotenuse, and the other two sides are called legs. Okay, we got hypotenuse, and we have legs. Okay. Here's another picture. Typically, the letters A, B, and C represent the lengths of legs. And it looks like that. And the Pythagorean theorem states that if you square the lengths of the legs and add them together, it will equal the square of the hypotenuse. Whoops. In other words, if this is a leg and this is a leg, A and B, the two shorter sides, if you square them, like take A times A and B times B, and you add those together, you get C times C, C squared. All right, if you square the lengths of the legs and add them plus, it'll equal the square of the hypotenuse. Okay, so if you square the legs and add them together, you get the square of the hypotenuse right there. It looks like this. A squared plus b squared is equal to c squared. That's true of any right triangle. Always. Every right triangle makes that true. So that means that if you know the value of one of the lengths and sides, you can always find the other one. That's what's nice about this. Let's look at a really simple example. How about this one right here? 3 is the leg, so the Pythagorean theorem says a squared plus b squared is c squared. Okay, so if a is 3 and b is 4, what we want to do is find out what does c equal. So if I square a, 3 squared, plus square b, 4 squared, that would equal whatever c is squared. Okay, 3 squared is 9, right? Plus 4 squared is 16. That's equal to c squared. 9 plus 16, well, that's 25. Now here's the new piece for you. Hopefully you're okay down to that point, because we really just did some really first chapter math there. Order of operations, right? You do the exponents first and then you add, get down to 25. But the problem is you don't want c squared, your goal is to solve for 1c, not c squared, or just think of c equals. So if I take the square root of c squared, all right, if I take the square root of c squared, I would end up with c, because c times c is equal to c squared. Okay, so if I take the square root of c squared, and I also take the square root of that, I get 5. And the value of c is 5. Okay, because again, you have to go from, you've got c squared here. This is probably the step where if you're confused, you're like, why did I do this here? It's a perfectly reasonable question. Well, you're trying to get 1c. So if you consider, let me show you an example why we did this. An example. Okay, let's say I have 5 times 5 is equal to 25, right? Okay, so 25. So the square root of 5 times 5, think of it like that. The square root of 5 times 5, that's the same thing as the square root of 25, right? Square root of 25 is the same thing. 25 is 5 times 5. And we know that the square root of 25 is 5. Oops. Sorry. Is 5. Okay. The square root of 25 is 5. So square root of 5 times 5 is 5. What about 36? If I had the square root of 36, well, isn't 36 the same thing as 6 times 6? And what is the square root of 36? It's 6. All right, so if I said square root of c squared, that's the same thing as the square root of c times c, which would equal c. It follows the exact same patterns I showed you here and here. So this is the new step for you. If you have c to the power of 2, you have to square root that value in order to get 1c, which is the goal. All right, so this particular triangle, is the lengths 3, 4, and 5. Now, here's a really famous picture to show you on the next slide. Strange, isn't it? Okay, let me show you what we just did. Let me remind you. Let me go blue here. All right, we know that a squared plus b squared is c squared. Okay, and we also know that that triangle on the previous slide was 3, 4, 5, which is actually a really famous triangle. So here's 3, right? This is 1, 2, 3. So this is 3, 1, 2, 3, 3 by 4, 1, 2, 3, 4 by 5, 1, 2, 3, 4, 5. So you have a 3, 4, 5. Now, it says a squared. Okay, so here's a. If 3 is a, how many squares make this up? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 squared is 9. Okay, and here's 9 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 4 squared is 16. In other words, it's a 4 by 4 square. 1, 2, 3, 4. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 squares you'd have here. Okay, well, if I add these squares, 16 squares plus 9 squares, that would give me a total of 25 squares. Count these squares right here, 5 by 5. 1, 2, 3, 4, 5, etc., 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 25. See it? So a 3 square and a 4 square make a 5 square, and see how the perfect triangle fits there. That's where the Pythagorean theorem comes from there, technically. So it's a great visual for what it is and where this actually comes from for you. So that about does it for this video. I've got one more to do. Next video we will solve some examples of the Pythagorean theorem, and then you'll be done with chapter 9.